My name is Andrew Cron from UBC in Vancouver, and we're going to discuss how to measure the QT interval. First of all, I draw your attention to measuring the QT interval in all 12 leads. We usually look at the maximum interval. I would just caution you not to measure the QT interval when the T wave is very low amplitude. Usually you focus on lead 2 and V5. These are the traditional leads to look at because they have the maximum amplitude, most bell-shaped T wave. There are two major techniques for how to measure the QT interval, and the key element here is the end of the T wave. One technique is the threshold technique, illustrated on the left here, where the amplitude of the T wave falls below 0.1 millivolts, and then you determine when the end of the T wave is. I recommend a more reproducible technique, which is the maximum slope technique on the right side. There are two main techniques, and the one I suggest is the maximum slope illustrated at the top right. Here we simply draw a line on the steepest slope of the downslope of the T wave, and where that line intersects with the isoelectric line constitutes the end of the T wave. Let's go through some samples just to illustrate how this technique works, and that can help be a good exercise to make your skills even better. So we've amplified two leads here. One is lead 2 and V2, and if we start in lead 2, what you see here on the top right is identifying the isoelectric line. That isoelectric line typically goes through the PR segment and the ST segment. Then the onset of the QRS is noted, whether there's a Q wave or an R wave. Then we draw a line through the maximum slope of the T wave, and that intersection constitutes the end of the QT interval. In the lower panel, here's a lead with a low amplitude T wave, so I generally discourage you from reading this, but the same technique can still apply. Once again, what we do is we identify that isoelectric line, similar to last time, the onset of the QRS, and then use that maximum slope in the upslope to identify the end of the T wave and the QT interval. This can be even more challenging in situations where you have high heart rates, and this is illustrated in this ECG, where it can be difficult to identify when the end of the T wave is. Let's look at this in a more magnified view. So we see here the maximum heart rate with the fusion between the P wave and the T wave. Again, go through the same exercise with the isoelectric line, the onset of the QRS, and draw the line through the portion of the T wave that you can see, that maximum slope. And again, that intersection point constitutes the end of the T wave, and you measure the QT interval. Here's a second situation that can be challenging, and here the tip is to ignore the shoulder of the T wave on the downslope. And again, let's go through that same exercise and look at this. When we look at the magnified lead 2, we see a nice bell-shaped T wave with this prominent shoulder. Identify the isoelectric line and the onset of the QRS, and then draw your line through that maximum slope to identify the end of the T wave, and thus assign the end of the T wave and the QT interval. I hope this exercise has been helpful to you. Have a nice day.